Hello and welcome to our today's webinar, From Process to Performance. My name is Daniel Knab. I'm a technical sales manager for Turnkey Solutions, and my colleague.
Hello, also from my side. My name is Jan Gotthold. I'm product manager for automation solutions at EMAG.
Well, today we will show you how we are coming from single. Once again, feel free to ask questions. Here we have two functions. The first function is the chat function. When you ask a question in this function, you will have everybody will see your question. When you have the question function, then our technical support will forward this question to our. Then we will look into from process to performance. We are giving you an overview over all the technologies that will come out of EMAG. Whenever this is not enough, we can also combine technologies in one machine. So in best case, you can save one entire machine. After that, we are looking at automation concepts and automation products, which are also coming out of EMAG. After all, we will end in our big turnkey solutions, where we have high productive production systems to machine every part that is necessary. At first, we are starting with the technology of turning.
Exactly. So let's have a little bit deeper click on the technology of turning. Let's start with our modular standard machines. Our modular standard machines mean that we have a huge kit of options on these machines, which you can select and find the best fit for your usage. We separate between the VL machines and the VT machines. The VL machines are equipped with a pickup spindle, which can load itself. And the VT machines have the turrets inside, and on the turrets you have the gripper, which can also load the workpieces from the outside directly to the workspace. The VL machines have the focus on jug parts, and VT machines are designed for shaft parts. And both machines are vertical turning machines. This is very safe spacing and is very good for the performance. We have very strong machines here. And within the modular standard option kit, you can find your individual machining solution in the very best way for low cost per pieces inside the machine. And it's perfect adjustable to your needs. Like I already mentioned, the machines are equipped with this O conveyor where the machine can load itself. But those conveyors can also be replaced by shuttles, bring us to the better possibility for automatic loading by an external automation system like a robot or a gantry system. So far about the modular standard machines, and let's have a look at our customized machines.
Yes, so whenever the modules of the modular standard machine series are not enough for your needs, we also have the possibility to build and offer a customized tool. Here we have very wide various of machines with maximum performance, and still we have the advantages that Jan just mentioned, the space-saving vertical machining spindle and self-loading pickup spindles. For instance, here we have the VSC series and the VLC series. These two series are also built for jug parts. We have here single, twin and duo machines. Just to say a few words about the difference between twin and duo machines. The twin machine, there you have both of the machining spindles on one slide. That means they can only differ a few millimeters. When you have a duo machine, you really have two separate working areas, which means you have basically two machines in one. Then we also have the VTC series, which is special designed for shaft parts again. Here we want to point out two machines out of this series. That's one, the VSC 315 Duo KBU. This machine is special designed for making parts for CV joints. Then we have the VSC 250 Duo. This is a very powerful machine, and we have a wide range of workpieces that we can machine with it. The loading principles overall, the customized turning machines is always with an shuttle that goes behind the working area through the machine, and onto that we can also equip it with gantries, with robots, with conveyors, with whatever there is need for. Then we come to our next series of machines, the classic line, and Jan will give an overview of all that.
Exactly. Our classic line family is a new family inside the scope of supply which we offer to you. And these machines, we picked out 3 examples which we want to introduce to you. The MSC5 Duo is designed as a double spindle machine with the internal handling system. And on the left and right hand side, you can see in and out feed conveyors for raw and finished parts. The HSC1 is also a horizontal turning machine, which can be easily equipped with a bar feeder for better autonomy, and can also be equipped with a manual loading door for taking out the finished parts automatically as well. And the USC 850 is a very huge machine, which we have for big parts to be produced on this vertical horizontal machine with a length up to 1 meter. So far in a very short way about our classic line. And within this, we change over to the next technology provided by EMAG, the grinding technology.
Correct. So whenever the quality requirements are higher than we can achieve in turning or hard turning, we also have the possibility to offer here machines with the grinding technology. Here we have 2 examples of the very big variants of the EMAG machines. On the left-hand side, you see here the WPG7. WPG7 is designed for very small parts, and also the base machine itself. It's only 1.8 by 2.4 meters. So you see, you have very small footprint, but still you have very dynamic access and a very powerful drive unit for the grinding mill. With that said, we are able to machine in very short cycle times, high volume parts. The loading concept for this machine is either manual, but when you take a look at the short cycle times, you might want to select an integrated loader that loads the parts directly into the machine. Then on the right hand side, we have the HG208. This machine is built for parts up to 800 millimeters. And the absolute specialty about this machine, we can include up to 3 grinding wheels within this machine on a moving B-axis. That means you can have many features machined in this machine in one clamping operation that keeps your quality really on a high level. The loading, as I mentioned already, is either manual or with integrated loaders, which then can be accessed by gantry, robots, conveyors, or whatever there is needed. So this is the grinding machines. We also have classic line grinding machines and this will be shown by.
Thank you very much, Daniel. Exactly, as already mentioned, we enriched our scope, our portfolio with the classic line also in the grinding. So we offer to you, there are 2 different families, the UG and the PG. Both are horizontal turning grinding machines and very universal in use. So the UG family is for the range up to 1 meter, and the PG is also able to produce parts with 2 meter length. And this, is an additional scope of supply which we can deliver in EMAG quality on the classic line. So far about grinding, and let's go ahead with the next technology which we want to introduce, which you can get out of EMAG, is the gear machining.
Jan, before we start with gear machining, we already have our first question here. Why is there a classic line and modular standard? What is the difference between those two lines?
Okay, so if you take a look at the customized machines, they are very individual. So they are very flexible, and they are exactly and 100% designed to your needs. If you go to the modular standard, as I mentioned before, you have a kind of option kit which is very flexible and very well designed. So you can take out of these options the best fitting solution for your demands. And the classic line is even more focused on the essential production, and we get these basic machines from selected partners and put on these machines our technology and knowledge about the production. So the clamping devices, the tools, and also the production technology is provided by EMAG on these third-party basic machines. Brings you to the situation that you can get the EMAG quality on a very cost-efficient way, and also very interesting for soft turning. So this is a scope we have on mind, more in focus with the classic line machines.
Okay, perfect. Then as you already mentioned, we are hopping into the next technology, the gear machining. Also for gear machining, EMAG can offer a number of machines. We have solutions for straight, helical, or even for worm gears. And for instance, we want to point out here the K series and the CLC series. The K series is a horizontal gear cutting machine for, let's say, smaller parts. We can have here an integrated loader with two loading and unloading arms, which makes the workpiece change over time to a very minimum. Then we have on the other hand side the CLC machine. This is again a vertical machine as it is known from EMAG. And here we have a ring loader system. That means we have two positions where we can load and unload parts. And there we can have also the possibility to equip it with 4 positions. That means we are able to implement other features or other functions as well, such as chamfering for it. This is the overview for the gear cutting now, and we are maybe we have some more requests regarding the quality of these gears and what is EMAG doing then?
Yeah. Obviously grinding. After hardening the parts, we can do the grinding to reach the final quality that is needed for these products. And we can grind exactly the same profiles which we have cut before. So we can do a grinding of straight and helical, internal and external gears. So we are very flexible in here. We have, for example, the G116, which is a vertical grinding machine. And by a very cool and clever arrangement of the internal axis, we have very short part changeover times. So the G160 is one of the fastest gear grinding machines all over the world. The G500H, for example, this is a horizontal machine for a huge scope of grinding applications. And this machine, for example, has linear motors on the main axis to provide a very strong and reliable system and a very quick system as well. And as you can see it here, both machines are, like always, prepared for manual loading, but can be also equipped with automatic loading doors to be able to be connected with a robot or a gantry system. So far about the gear technology, gear grinding, gear cutting technology. And let's go ahead to the next very fancy technology, which is maybe not that known. So Daniel, please go ahead.
Thanks. Yes, as Jan already mentioned, the ECM, the electrochemical machining, is not that well known. That's why we decided to give a little overview how this technology works. Here we have a non-contact machining, which means we don't have any thermal or mechanical effects on the part. As you can see in the little sketch, our workpiece is at the end the anode, and our tool is the cathode. And the cathode is exactly in the shape that we want to have the workpiece at the end. Then by giving electrical pulses on the part, the material will be removed, and the electrolyte that connects both items will then move the parts or the removed material out of there. The specialty about this technology is that we have really good surface qualities at the end, and the hardness of the material. It does not really matter. There's not a big influence in the process, so we can also machine very, very hard or very range material. Here we have two examples. The PI and PS machines, they are vertical machines that we are often using for rifling of gun barrels. And with normal cutting technologies, you would not have even the ability to machine something inside of the barrels. Then we have the PO series in the size 100 up to 900, where we can machine also bigger parts. And for instance, here in the picture, a turbine wheel, which is a very, very strong material usually. But yeah, the technology can handle that. Loading principle, as usual, we can have manual loaded machines, but we can also automate the front doors of the machines, so external automation can be installed as well. So this was the first non-contact machining that EMAG offers, and then we go into the next one, into the laser.
Exactly. Thank you very much. So laser machining, within laser technology, there pops up a complete new universe of use cases. Because with laser technology, you can put energy very local and very direct at one place of the workpiece. So you need high energy at one place, and then laser technology is very useful for that. And use cases for this are the laser welding, which is very well known. By laser welding, you bring in the energy, as I mentioned, very local. So the workpiece itself does not get that as hot in total. And regarding deform of the workpiece, you have less trouble within this. And also very interesting is the laser cleaning. We often combine this, that we do cleaning before laser welding. So these technologies are very often used directly after each other. And also the laser hardening is very interesting, because if you have a workpiece which need to be soft in total, but you need hardness at only one point at the workpiece, then the laser technology is perfect as well, because with a laser beam you can bring energy very local at one position, and the rest of the workpiece is not influenced by this. And as a fourth option, we have the laser cladding, for example here on brake discs. As I mentioned, we often combine these technologies, so automation is obviously inside, but they can also be interlinked very easy by outside external automation solutions. A very new field for us is, that's why we want to show the EIC 2500 to you. that we do laser welding, also not only on rotary parts. So we do this also on flat, huge parts, like for example, coolant devices for batteries. Within this, we do the laser welding by a gantry inside the work cell, inside this machine, which gives us very, very good results with different kind of shapes. So far in a short way about the laser technology, and we want to take a look to the combination machines right now.
Exactly. So now we have seen an overview over all the technologies that EMAG can offer. Now in case we have more demand and we want to combine two technologies that are very close in the process chain to each other. For instance, turning, grinding, milling, drilling, power skiving. This gives you a very high flexibility, as you can combine them as needed. All of our combination machines are based on the VLC or VSC series. So we also have them, as we mentioned earlier, in single and duo versions, or on the VTC series. Here we want to point out two examples. The first example is the VSC 400 PS. Hereby stands for power skiving. Means whenever you have a demand of cutting a gear on the inside or the outside and turn or pre-turn this diameter, this will be the go-to machine. We can do both operations, both technologies within this one machine and within one clamping operation. Then on the right-hand side, the VLC 200 GT. GT hereby stands for grind and turn. A lot of you will know whenever a part is coming back from hardening process, then you most likely have to pre-turn a hardened part, and then maybe for quality reason you also have to grind that after. When you have single technology machines, you have now two machines. You have to automate that somehow, or a worker needs to bring the parts from machine to machine. Here we can do both for everything in one machine. You will only have to place the part once, then we can do the pre-turn, we can do the OD grind, and we can do the ID grind, because this machine is capable of being equipped with two grinding spindles, so we can do ID and OD, or two features OD. That's also not a problem. Regarding the loading principle, we still have the same solutions as we have with the series which we are basing off. So that means we either have conveyors, we have shuttles, but we can extend with gantries, robots, or conveyors. So now, we see what is possible within one machine. If that is not enough, if we need even more flexibility or more productivity, we somehow need to interlink machines with the same technology or also with other technology, so multi-technology. And therefore, we need something in between, the automation. It's an important field, and we now want to take a look at the automation concepts that EMAG can also offer here.
Exactly. And as EMAG, we think about automation as similar as the machines. Our automation solutions should be handleable like the machines itself. So they should be very easy to transport, very easy to commission, and very easy to interlink with our machines. So this is the focus. And how this could look like as a starter, we would have like to have a look at this small animation. Here you can see a VR machine classically equipped with the old conveyor for manual loading. This can be easily replaced by an L-shaped loading shutter to be connected to any kind of automation. In this case, you can see a robot work cell with two machines on the left and right hand side. This is one very classical setup. But you can, if you need even more machines inside one production chain, you can use, for example, our track motion system, which is available and interlinked the machines one to the other directly. Yeah, so far as a starter insight to this topic, and we would like to introduce, as I mentioned, our products a little bit more detail to you. And here we can start with the track motion.
Yes, so looking at the track motion system is perfectly designed or only designed for automating the VT and the VL series, so the modular standard machine. It comes with an own control, which means the complete automation and everything that belongs to it will be controlled by the track motion. The base of the track motion is also modular designed. That means we can adjust the length in different modules. We have modules with 800, 600 or 300 millimeters, and we can put them together as we need it. Then on the base of the track motion, the trans lift sits. It has an x-axis where it can reach the single machines. It has an z-axis where we can lift and place the parts on the shuttles. We have a turning or a flip over axis, a c-axis, where we can flip the parts. And we have an electrical gripping unit. This is advantage of this is that we can program the diameter that needs to be gripped. In most cases, that leads to nothing that has to be changed over when we have to machine another part. This was the overview for the track motion, and we are now looking at the SCS4 stacker cell.
Exactly, and the focus of the stacker cell is not the part handling, it's the handling of the baskets, the wire baskets, which you maybe know very well from your own production because they are available almost everywhere for the internal logistics in the production. So the concept of this machine is that you feed in a complete stack of baskets to this machine on a floor roller, and all the rest of the automation of this machine is the handling to destack all these baskets and bring them to the loading and unloading position on the top side, where the external automation system can pick out the parts and load them after machining in again. So we have 3 buffer slots inside, brings you to a higher autonomy and a very flexible usage of this machine. So for example, you can use it in front of line. If you only feed in raw parts on the basket, then all the raw parts baskets are provided one after the other on the top side for taking out the parts, and afterwards the empty baskets are stacked again, so you can take them out very easily after that. In the end of the line, it's possible exactly the other way around, that you put in only empty baskets and they are filled within the SCS4 and stacked afterwards, that you can get out completely machined parts stacked on the floor roller again. Or you can use it in a mix operation, that you feed in the raw parts, they are buffered inside and provided to the handling one after the other, and the finished parts are already placed inside the baskets and then feed out after they are stacked again to the front door. We are also flexible for AGV loading. We are prepared for this by an automatic roller door. So even if you use already AGVs in your production plants, we can integrate our work cell very easily to your workflow. So far about the SCS4 as one example from our productions in case of automation. And now let's have a look at the CRC.
Yes, we are now looking at our first robot cell, the compact robot cell. As the name already shows, we set here the focus on the minimal footprint. This machine is also designed to be placed at an EMAG machine, which is able to handle small parts. For small parts, we also often have small or short cycle times. That means we need to be able to load and unload while the robot is still working. And I will explain how we do that. When you take a look at the cell, in the front you have the door. Behind the door we have 4 levels of chutes where we can put in pellets with raw parts and empty pallets with finished part. There is also the possibility to have here a mixed production, which means you can select maybe 2 doing one job and 2 doing other jobs. When we go deeper into the cell itself, then we see here a little loading door, or little door that shuts the robot from the loading area. So whenever we are opening the front door, we are safe to work in, and the robot in the back can still function and do his jobs. This is also a good solution for quick installation, because everything can be pre-commissioned, pre-installed, and can be placed directly aside of the machine with a forklift. This is now the CRC, the compact robot cell, and we also have a bigger sister therefore, and this will be shown from Jan.
Exactly, thank you very much. So the MRC, as you already mentioned, is the big sister of the CRC, and the focus of the MRC is the modularity. That starts with the feeding principles, because we are very open. You have your production outside, you have your own containers, you have maybe pallets, baskets, or any kind of boxes where you handle the parts internally already. So we can adjust the work cell exactly to your loading principle you need. Even we can handle bulk parts. Then we have a separate camera module, a 3D camera module, which can detect the parts inside the boxes, and we can also handle bulk parts in this way. Since we can interlink the machines very nice, since there is space on the left and right hand side, and we can combine it also with a track motion if there are more machines in one line, so we are flexible at this point as well. And to increase the modularity, we decided to go not to the minimum footprint, because for small footprints we already have the CRC, so flexibility is the focus of the MRC. So we have some space inside for integration of secondary processes. As you maybe know, the automation cycle time is most of the time much shorter than the machining cycle time. Within this, we can use this time, the available time, the waiting time of the robot, for secondary options, like buffering parts inside to give you more flexibility in case of a workpiece box change in the front, a blower station after production to get the parts cleaned, or often we also use their measuring device, and we are open from technology which can be integrated there, or to mark the parts after machining. All those stations can be integrated to the MRC very easily and can be commissioned in there. That means they do not have to be disassembled after commissioning, and we can do the other commissioning at our site and deliver the complete line directly to your plant, where it can be set up very easily, and you have a very quick ramp up since commissioning already took place at our site. So far, in a very short way, about our automation products. Now we learned a lot about our machining technologies, the wide scope we offer here. We learned about the automation solutions, and now we want to go ahead how we can combine the machining technologies with our automation solution in order to reach high performance turnkey solutions.
And before we do that, we already have our next question. Does EMAG also offer only the automation systems or products?
As you know, our automation solutions are all equipped with their own control. That means they can be easily used as standalone technologies to load other machines as well. So you can get them easily and of course as single products out of EMAG as well. But the biggest benefit on my point of view is that we can provide both together, the machining technology and also the interlinking. And within this, you get a turnkey solution, which is much easier for you to handle. You have much less stress during the commissioning because you have one single face to a customer, and you can get all out of EMAG.
Everything out of one hand.
Exactly.
Okay, perfect. Thanks for answering the question.
Welcome.
And we will now take a look into the turnkey solutions. So we just looked at how to interlink our EMAG machines, and now we want to show you a few examples what we did so far. The first example is for medium-sized batches or volumes. You can see here 4 machines interlinked with track motion systems. We have 3 machines doing operation 10 because the cycle time is very different to the operation 20, and only 1 machine doing the operation 20. So it's also balanced within the line. When you take a look at the layout, then you see the worker has to place the raw parts on the raw part conveyor, and then the machine or the line will load and unload itself. That means the track motion takes the raw parts and delivers it to one of the OP10 machines. After that, it takes it to the OP20 machine and turns it around. And after that, again, it takes it to the finished part. So only for the raw and for the finished part, we need actually a human who is doing the job. Everything in between, the system handles itself. Then let's assume you already have this system as it is in your works. But now you see a demand of more volume, higher volume. What can we do about it? That we can see that in the next slide. Here we multiplied the whole line by 4. Means we removed the loading conveyor on the left side and the unloading on the right side. We do now both on the left-hand side of the line. And on the very left, we installed a robot on a 7th axis, which is linear, connecting all the lines together. This robot feeds himself out of a raw part bin or raw part pellet and feeds it into each individual line. After the parts have been machined, the parts will be then cleaned and brought to the finished part, conveyor or bin. Here you can see how easily we can multiply or extend the production for every possible need, and you have a very high autonomy because depending how big you make the raw and the finished part pellets, you can even reduce a whole shift. Then we have seen an example about the modular standard series. We now want to look at a big project with a classic line machine.
Exactly. What you can see here is an ongoing project which we are realizing right now. It's a combination of 10 USC 850 machines and for very large batches in this case, because we have 10 times OP10. This is a kind of special at this since the batches are very, very big. As you can see here, we also use the robots for loading and unloading, but the USC 850 is prepared for top loading. That means the robot is moving above the machines on a 7th axis, and this is a very safe spacing principle since the linear axis is directly above the machine. And within this, you also have a very huge accessibility, perfect accessibility for the operator to the machines. Since the robot and the automation comes from top, the front of the machine is still available for the operator. And all machines are available from the same side, so the operator has very short ways from one machine to the other. Also, we can deselect single machines very easily from the automation without stopping the automation, for example, for tool change or maintenance, stuff like that. And since we do not have to stop the complete line, this brings us to a higher overall equipment efficiency. And also this complete line is scalable. Now we have 10 machines, but you can scale it down and upside in both directions according to your demands. So let's have a little bit deeper look at how this work cell is operating. So we have an in-feed conveyor in the middle, which is available for both robots. On this in-feed conveyor, we do a code reading because the parts are already marked while entering our work cell. And we have to read this mark because it will be destroyed by the turning process because we are turning over the surface. And then we have to do a re-marking after operation. From there, we have the two 6-axis robots picking the raw parts from this conveyor. And after reading the code, they forward those parts directly to the machines where they unload the finished parts and load the raw parts again. Within this big line, chip management is very important for us since the complete line will produce about 1 ton of chips per hour in full production. So this is a huge amount and we have to take care about this also from the planning. Otherwise we get in trouble during the production. As I already mentioned, after machining we have to do the marking again before we feed out the parts to a separate measuring station where the parts are loaded to a measuring device by robot again before they get fed out to the next external operation. As you can see here, it's 10 machines, 2 robots. This is not that small line, in total 45 meters in length. And this is also a huge invest for our customers. And if you do a huge invest, of course, you're interested about the performance of the system. And that's why we do an OEE simulation in the very beginning. That means we bring some input parameters to the system, like the cycle time of the machine, also the cycle time of the automation, the availability, the technical availability of the machines, and also the mean time to repair of all the subsystems, like the machines itself, the robots, the marking system, and all the stuff. Also, the tool life is very important because we have to find out how often we have to change tools and if it is the possibility of the sister tool management to make this even on a higher level. Also, the tool changing times are important and the not okay rates. I think everyone knows that it would be nice to have 100% okay parts, but this is not the reality. So we have to take not okay rates also under consideration. And some organizational stuff like days per year and shifts per day and also hours per day. And all those input parameters we bring to this simulation tool. And as a result of it, we can get the estimated line cycle time. And also we can identify bottlenecks if we have maybe 2 operations in this line or even more operations. Maybe we find out that we have to parallel 1 operation to make the complete line smoother if we have to integrate some buffers in any position. And within this, we get the overall equipment efficiency. And the most important point, of course, for you as our customer, the production capability of this complete line as it is running at your site in the end of the project. So far about this use case. This was realized, both cases has been realized with 1 type of machine. But our big goal is bringing high performance production together. And this will be supported and explained by Daniel within the next part.
Before we head into the next example, we have the next question here. And the question is, what about the integration of third-party technologies? I would like to take the opportunity to answer that in a very short way. And the answer is yes. We, of course, integrate also third-party technologies. We have seen the overview of what EMAG can offer, but of course there are some others that might are necessary for complete production line. So yes, we are including them. And during our next example, this also will be part of that. So as you can see here, we have a drive shaft, and the examples we have seen before are most likely only turning and only the same machines. Here we are focused on producing the part completely from the beginning to the end, which means we have different and multi-technology machines in here. Let's go through the layout. At first we have the bar loader and we have a saw. That's the parts length. Here you can also see that's a third-party equipment that we have to integrate and that we are happy to do. Then we have a small buffer conveyor that feeds our track motion. After that we have the two operation OP10 and 20 with a VTC 200 that is specially designed for shaft machine. Then we have the gear cutting machine, which is operation 30. The last step here is the cleaning of the parts and then a handover to the end-of-line robots. And now it was important for us to also prove that we can build such production systems and not only show nice pictures or models. So we have prepared a small video of exactly this line, and we will go step by step through that and explain what we are doing here. So here, once again, you see the overview over the machines that we just discussed about, and here the end-of-line robots. So we are beginning with a complete bar. We are cutting the parts to length as we need it for our first turning operation. Then we are moving these parts to a small buffer conveyor. The track motion grips it in a horizontal way and places it vertically in our changeover-free pallet that you can see here. Now the integrated gripper on the turret takes the part and feeds it directly into the machining spindle. The machine then itself makes the face and center that we can afterwards place it onto the tailstock and have a really solid and really stable clamping operation. Here you can see the very nice specialty about the VTC machine. We have two turrets cutting the part at the same time. That means we can we have a very short machining time and very good machining. Then the part will be removed again. The track motion comes and brings it to the next operation. Here we also see a small buffer station to buffer times when, for instance, a tool change is necessary. Then we go into the operation 20. We will now see a EMAG internal special chuck for shaft machining with retractable jaws. By having such a chuck in the machine, we are able to build up a lot of torque while doing the rest of the rough machining, as you can see here. And then when the rough machining is done, we are retracting the jaws from the part, so the complete part is free, accessible for turning tools, and then we are finishing the part completely in this one clamping situation. That means no clamping faults, everything between cylinders, and the highest possible quality. Then the part will be transferred to the next step, to the gear machining. Here we can see the integrated loader with two arms that loads and unloads at the same time or with one movement. Here we can see the machining of the line or of the gears. Especially here we can do both gears in one machine. And also, while driving backwards, we can chamfer this gear, which means the gear is finished for the moment. After that, the part will be moved again backwards to the track motion system and will be then prepared for the next step. Yeah, here the loader loads the swivel table. The track motion takes the part then from there, and it goes to the last job for the track motion, to the cleaning station, because the cleaning is necessary for the rest of the process line, which Jan will now explain in detail.
Exactly. And cleaning station is, of course, for cleaning, but it's also the separation between the control cycles, let's say the control range of the track motion and also of the robot workcell. So if there's any issue at one side of the track motion, the robot can continue, and the other round as well. The robot loads the parts after cleaning directly to the measurement device, also third-party integration, which we have here. And if the part is okay measured, we continue with the marking of this part. In this case, we have a needle marking system inside our workcell, and to take the force and for better marking results, we place the part inside this prism. Also, laser marking would be possible inside this workcell. This depends on your demands. In the front, you can see the baskets, which will be taken directly into the furnace for hardening. So even the parts are placed inside. The operator just have to take out the baskets, which are available on trolleys, and feed them directly to the furnace. So we come from the bar loader, and we finish with a finished part inside the basket for the furnace for hardening. So we cannot start earlier, and we cannot finish later. So the complete production is built here without any manual operation, and we are on the straight line for lights out production with solutions like that.
Perfect. That's now almost the end of our webinar here. To sum that up one more time, we made our way throughout the different technology that EMAG can offer. We looked at how we cleverly combine more than one technology in one machine, and we took a look at what happens after that. If that is not enough, how can we automate, and how can we put that into high-performing production lines? So at the end of this webinar, we want to point out, no matter what your demand is, whether it will be a single machine, combination machine, or a demand for a high flexible and high efficient production line, please contact us or your local EMAG contact, and we are happy to help, and we are very sure that we will have the best solution for you as well. Thank you for your attention, and see you next time.
Also, thank you from my side, and bye.